All right, let's take care of this last problem. This last problem is going to be, it says the term in years of a $200,000 home mortgage at 7.5% interest can be approximated by what? All right, $200,000 home mortgage, that's not that expensive comparatively, but let's do it anyway. 7.5% interest is kind of a bad interest rate, but let's see what happens here. You really want, mortgage rates now are like 3.5, maybe 3.75 to 4.5%. Let's see, and average home price, I think, I don't know, like 500,000, 500,000. Okay, so let's use a graphing utility to graph the model. I'm not going to do that one. You can graph that on your own, graph on your own. Let's do the next one. Use the model to approximate the term of a home mortgage where the monthly payment is $1398.43. So looking at the words here, it says looking at approximate the term. The term is T, so I'm solving for T. It also asks for what is the monthly payment. I'm sorry, the monthly payment is $1398. X is the monthly payment, so that's just saying that X equals $1398.43. Okay, so I need, first of all, I need T of X. Now let's do T, yeah, T of 1398.43. And let's see what that is here. I'm going to open up Desmos. Still waiting for Desmos. Okay, here we go. Let's do T equals, so T of X equals 13, what is it? Of X over, whoop. For X is greater than. Obviously I can't see the graph here, so I'm going to go and just adjust the window. It says X has to be greater than 1250, so let's get rid of this one to 1250, and let's go ahead and go to, these are going to be X's payment, so let's just go up to 1600. Let's also do Y value. Y value is going to be the term, so let's go and do from 0. Let's go to about 40 years. Curve. Okay. All right, so next we want T of 1398.43. Okay, here it is. And that value is checking everything. Okay, looks like that's going to be 30. Okay, so the time here is going to be 30 years. So how much do we end up paying? Well, the total amount paid, that means I'm paying 1398.43 per month. So let's see what that is. Now we got 1398.43 times 360. And I'm actually going to do something here, a little trick. Just want to make this easier here. There's still, let's label that. Let's go ahead and do 8 times 360. $503,000, 434 and 80 cents. $503,000. So we get $503,000, $503,434.80. Notice how much over that is for 200,000. So we overpaid by a lot, and what we're paying is we're paying interest. So this is kind of helpful information for you when you're older, much, much older, is that when we take that 503,000, 434.8, and we subtract the 200,000, that is how much we paid in interest, which is 303,434.8. So we paid more than the house was worth on just interest. Ay, that is not good. That is not good. Okay, let's go to C. For C, we need to do same thing, same exact thing. The monthly payment is X, X equals this. 0.19. We want to find the total amount paid. So let's find what the term is, first of all. So what is the term of a home mortgage? So let's do T of 1611.1. T equals 1609. Let's go ahead and do T of B and see where this is at. Label, here it is over here. 20 years. Oh my gosh, 20 years. Okay, so this gets us 20. Okay, so that's 10 years. Okay, let's see what happens here if we do some math. So how much did we pay altogether? So we're paying 1611.19 for 20 years. So this is again per month for 20 years. So let's multiply 1611.19 times 360. Let's do B times 360. 580,028.4. 580,028. Oh, hold on. Not 360, not 360. We only did it for 20 years, so we're going to do 12 times 20, which is 240. Okay, not 360. That was almost a big oopsie daisy. There we go. That looks a lot better. 386, 685.6. 386, 685.6. Well, the conclusion should be pretty quick. It looks like for this one, we're going to have to pay only 186,000 and 685.6. The question isn't asking this, it's just giving you extra information. That's 186,685.6 in interest. Okay, so that's an interest, which means that that's a way better deal. Let's see, what else do I want to tell you here? That's a better deal because if you pay approximately, what was 16, if you pay $212 more a month for all that time, for 20 years, so you keep up $212.76 a month for 20 years, you can pay off the $200,000 and save yourself a couple $100,000 in interest. I mean, it's a good deal. So the idea here is that when you have an when you have a mortgage, and I know that you guys are a little bit away from having your own mortgage, maybe not, I don't know. If you have a mortgage, key is to pay off more sooner. Right now, I'm not going to tell you how much I pay for my mortgage, but I do pay more than the required monthly payment because I know that all that extra money that I'm paying goes towards interest so I can get closer and closer to paying off what my mortgage is. So if you have a mortgage, the key is to pay off more sooner. The more you pay in monthly payments, the less interest you have to pay. I'm not sure what interest is because I don't know what your experience is with this kind of stuff. Interest is how much you pay for the bank to loan you the money. So in other words, someone's giving you money, they want something though, because they know you're not going to pay it back immediately. So they ask you, I'm going to ask for a certain percentage each month that you haven't paid this back. You pay, you keep paying over and over and over again, all this interest, and it all adds up. The sooner you pay it, the less interest you pay. The more interest, the more you pay, the sooner you pay off the loan, the less interest you give to the bank, the longer you take with it. So if you're not putting as much as you could towards it or you're doing the bare minimum, you're going to have to pay the full 30, mortgages are usually 30 years. You'll have to pay the full 30 years and you're paying a lot of interest. So this problem is a really good problem to exhibit that. Let's just look at what D is asking for. D is asking for find the instantaneous rates of change. All right, let's do it. T prime, because it asks for instantaneous rate. Let's do t prime of a. So what do these numbers mean? Let's do t prime of 13. T prime of 1611.19. That was t prime of 1383. And that's equal to let's think. So X represents months, payments, monthly payments. And Y, T, represents years. So it looks like when you're paying 1611.19, the term is decreasing by about 0.02 years each year. Let me type that out for you. Oh, actually, it doesn't even ask for the interpretation. Okay, I don't know why I did that. So a short paragraph describing the benefit, I'll put that here again. And lower your monthly payment. Okay, that's it, guys. Thanks for watching this video on number 103.